All right, so going to be talking about the transformations of quadratics, okay? Now, we kind of just hit on it just a little bit. The last lesson that we did when we were talking about vertex form, okay? But you guys are going to be able to understand the effects of A, H, and K on a graph. Now, that will span between today and also on Friday. So if you already know that you're going to be absent on Friday, please make sure that you get the lesson from me before you go, watch the video on Schoology, and make sure that you do your work, okay? And actually, hold on. So, what shape is our quadratic function? It is a parabola. Parabolas look like what? Looks like a U. Okay? None of this resting. Okay, so we have 0, 0, 1, 1, 2, 4, 3, 9. And of course, those reflect over. And what is the vertex?
0, 0.
It is 0, 0 for this particular function. But in general, what is the vertex?
The highest or lowest part.
It's either the lowest or the highest on the graph. And you guys, it is a coordinate, okay? Which means you need to include the parentheses. I don't know how many times I had to write that on homeworks, but yes, it's a coordinate. Make sure you include the parentheses.
Like how we write the answer, it's like option.
Oh, don't forget. Don't forget. Cross those T's, dot those I's. All right? And all the transformations, again, they're based off of this parent function. So this original graph is going to move depending on, certain values. So for example, everyone open up the vertical translation part. Close up the horizontal part, okay? Here you have f of x equals x squared plus k. K represents some number. Now, if k is greater than 0, then the graph will be translated k units upward. That means the original graph is going to move however many of those units up. And if k is less than 0, then the graph will be translated symbol k units down. What does that symbol mean? Absolute value, okay? So that basically means that if you have a function, let's say it's x squared minus 1. What's k? K is a negative 1. So what has happened to the original x squared graph is not that it moves down negative 1 units, it moves down 1 unit because you take the absolute value of it. Does everybody understand that? So this example, you would say move down 1, not down negative 1. It's being redundant, okay? You're just moving down 1, okay? And then, of course, if k is positive, that means it's just moving up, all right? So if you look at these two graphs, again, close up the horizontal because I don't want you to get confused and put tables in the wrong spots, okay? This x squared plus 3, that means the original graph is doing what? It's going up 3 units, okay? If I ever ask you to describe what is happening to the original graph of y equals x squared, and I give you x squared plus 3, that means the graph is moving up 3 units, okay? So that's one thing. I may even ask you to create the table to represent this, okay? That means you're going to take the original table here, and you're going to move the graph up 3 units. Now, if I move the graph up 3 units, does that affect my x's or does that affect my y's? It affects your y's, okay? It always will affect your y's. K always affects, I think it's an E, not an A. It always affects your y's. So that means in the table on your original graph, you're going to add 3 to every single one of those y values. Your x's stay the same, but you're going to add 3 to all of those original y values. Look at that table. Look at that table for the original graph. You see those y values? Add 3 to them. What's 9 plus 3? 12. What's 4 plus 3? 7. What's 1 plus 3? What's 0 plus 3? I'm adding 3 to every single one of the original y values from the table that's sitting up there at the top that you guys have open, right? You see what I'm doing, where I'm getting these values from? What about the next one? It's going to be 4 because it was 1 plus 3. 7 because it's going to be 4 plus 3. Because it's going to be 9 plus 3. And then these are going to be the new points on the graph of this function. 0, 3, 1, 4, 2, 7, 3, 12. And so on and so forth. And what you should notice is that when you connect these points, it literally has taken the original graph and shifted it up 3 units. Does everybody see that? So K affects your Y's. If it's a plus 3 or a plus 9 or a plus 12, you add that value to your Y's to create your table to graph your function. What about number 2? What has happened to the original graph, y equals x squared? What's happened to it? It's going down 3 units, okay? Not down negative 3 units, but down 3 units, okay? Which means that, is this going to affect my x's or is it going to affect my y's? And what am I going to do to all my y values? Subtract 3. My x's do not change, but my original y values, those original y values are all going to get subtracted by 3. What's 9 minus 3?
6.
What's 4 minus 3? What's 1 minus 3? What's 0 minus 3? What's 1 minus 3? And it keeps going, okay? 4 minus 3 is 1, and 9 minus 3 is 6. The x will always be those numbers when there's only a k, okay? Only a k, okay? Okay. So let's plot these. Let's get them on there. And as you can see in your graph, once you connect all those points, the graph has moved down. The original graph of y equals x squared has moved down 3 units. Okay. Now listen to this real quick. Okay. If I just ask you to graph a function, graph a quadratic, you can do it however you like. If you're the type that likes to plug in points and work it out from the function, then that's fine, do that. If you are cool with doing the pattern, then that's fine, do that. But if I ask you to describe what is happening to the original graph, you need to be able to tell me, oh, it moves up 3, or it moves down 3, or to the right 3, or to the left 3. But I need you to be able to say that, like use those words. I may give you a table and give you a function. You may need to do what we just did right here of creating the table to represent this new function. Okay? Does everybody understand that? I'm not trying to tell you this is how you have to graph it now. No, I just need you guys to know how to be able to create the table. And again, the table gives you the points where you can just plot it. All right? Any questions on vertical translation? We'll close that one up. Let's look at horizontal translations, okay? Horizontal translations deal with H. There's a difference between a horizontal translation and a vertical one. Horizontals are inside of the parenthesis, okay? They're inside of a parenthesis. So if you don't have a parenthesis, you're not going to have a horizontal translation, okay? No parentheses, no horizontal translation. But if you do, you got to be careful. If H is greater than 0, then the graph is going to be translated H units to the right. And if H is less than 0, then it's going to be translated absolute value H units to the left. Remember, we don't say, left negative 3 units. No, we just say left 3. Yes?
Is H, is it the opposite of H?
And this is where you got to be careful. Let's take a look at an example. Let's say you have something like this. Okay? And you have to decide, is this going to move to the left or to the right? This is the general form. This x minus h is the general form. So that means that h is what number? It's a positive 1. Because think about it. I had to plug 1 into this formula to get x minus 1. So in this case, h is greater than 0. So I moved to the right 1 unit. All right? But if it's something like this, h is at -5 because I had to plug -5 into this formula, and that's how it turned into a positive. So then I move which way? How many units? Nope, 5. Not -5, just 5. Okay, it's always the absolute value of the number. Okay? Write down these examples if you need to. Okay? It is, yeah.
In the equation, if it's plus H, it goes to the left, and if it's minus H, it goes to the right.
Yes, that is true. If it's on the inside, if you look on the inside, if it's a minus, it actually moves to the right. If it's a plus, it moves to the left. This one is the tricky one. This one is the tricky one. Remember how we were talking about the vertex? Okay? Same type of concept. Let's look at this. Look at number 3. It's on the inside of the parentheses, which means it's a horizontal translation. Is that to the left or to the right? It's to the right. How many units? 3. Because remember, the formula is x minus h squared. So what value did I plug in for h to make it an x minus 3? It had to be a positive 3, which means it moves to the right. Now, these horizontal translations, they affect your x's, okay? So I'm going to put that in there. H affects your x's, which means that when you make your table, Your y's are the ones this time that stay the same. Okay? So all those original y values from the original parent graph of y equals x squared stays the same. But your x's are going to be the ones that change. If I'm moving to the right 3, what am I going to do to my x's? I'm going to add 3 to every single one of those original x values from that table that you guys should be looking at. These were the original x values. I'm going to add 3 to every single one of those. What's negative 3 plus 3? Negative 2 plus 3. Negative 1 plus 3. Noticing anything was 0 plus 3? What's the next one? What? 4? No. What's 2 plus 3? And what's 3 plus 3? 6. There you go. Yeah, just going straight up. So then this becomes the points on this translated graph to the right 3 units. Okay, so let's plot them. And when you look, it literally looks like you took the original graph and moved it to the right 3 units. Yes.
So the x, so that's 0, but the y is 9.
Correct.
So are you finding the square root first of it?
No, so here we're not even like trying to take these x values and plug them in. I mean, we could take them and plug them in and we'll get these. Okay? But basically what we're doing is we're using the original table. So this original table, these points right here, and we're changing them depending on what the translation is. So for that last one, since it was to the right 3, all of these stayed the same. They didn't change. But all of these x values were affected.
So to the right 3, doesn't that mean add 3?
Yes, but we add them to your x's. Your y's don't change, but your x's are going to be the ones that change. And the thing is that like if you have a problem like this on a homework, I'm going to give you the table. So you use those values to make your changes. Yes. Yes. Simultaneously. Yes, we will look at some. What about this one? Careful. It's on the inside, which means that it has to be horizontal. So it moves which way? Left 3. Which means that your y's, they don't change. But your x's are going to what? They're going to change. And you're going to subtract 3 from them because when we move to the left, going in the negative direction. So we're going to subtract 3 from every single one of those. Your y's stay the same, but these original x values, you're going to subtract 3 from them. What's negative 3 minus 3? All right, finish, fill out the rest of the table and graph the function. So when you subtract 3 from every one of your x's, then you're going to get negative 5, negative 4, negative 3, negative 2, negative 1, 0. So now the graph has shifted to the left 3 units. Not negative 3 units, just 3 units. Okay? All right. Let's look at one example where they're both together. Okay? Let's look at an example where they're both together. It's not going to be in your foldable. So if you want to add this somewhere, maybe on that page, maybe below it, let's do that. Okay? This is kind of what not this homework, but a future homework is going to look like. I'm going to give you a function. I'm going to give you a table. You're going to need to basically complete the table. Describe what's happening. Okay? That's 6. That 6 is on the inside of the parentheses, which means what?
Negative
left
6.
or horizontal.
It's horizontal translation, so it's going to move how? Left 6 units. Awesome. What about that negative 3 on the outside? It's going to be down 3 units. Very good. Okay? So anything that's on the inside is going to be a horizontal translation. Anything on the outside is going to be a vertical translation. Which means that, yes, in this case, both the x's and the y's are going to change. What are you going to do to your x's? Careful. You're going to subtract 6 from all your x's because we moved to the left. We can subtract them. And then what's going to happen to our y's? You're going to subtract 3 from them because we're going down. Okay? So then you just have to complete your table. What's negative 2 minus 6? Negative 1 minus 6. 0 minus 6. Yeah, you got more there.
So this is not, I thought this is the graph that we use all the time. We'll have different graphs that we'll use.
Well, actually, what this is it is that original graph. I just don't have the 3's. It is the original graph. It's only that section, though. I'm at 1. What's 1 minus 6? And what's 2 minus 6? So those are my new x's. My y's, I have to subtract 3. What's 4 minus 3? 1 minus 3. 0 minus 3. 1 minus 3. 4 minus 3. And so those will be the points that you apply if I asked you to graph. But here I'm just asking you to complete the table. Okay? One more. I'm moving which way? Left 4. You guys agree? Down 1. Do you guys agree? What would happen to your x values? Subtract 4. And your y's? Awesome. And then you complete that.